Hi, in this example, we're going to look at a practical example in putting a complex number in modulus argument form and looking at the multiplication of those and the division of those. So, express a complex number z1 plus is equal to 2 plus 2i and z2 is equal to minus root 3 minus i, and write them in the form r cos theta plus I sin theta, and hence find z1, z2 and z1 divided by z2. Okay, so z1 is that, z2 is that. You should represent these both of these numbers on an Argand diagram. So let's do 2 plus 2i. So it's going to be 2 along and 2 up. So it's going to be there. Okay, that's the complex number. This is the angle, and this is the modulus of the complex number. So we've got z1 is equal to 2 plus 2i. The magnitude of that, or the modulus, is going to be the square root of 2 squared plus 2 squared plus 2 squared, which is the square root of 8, and that becomes 2 root 4, which is square root of 2 times square root of 4, which becomes 2 root 2. Right, the argument is going to be this angle here. You can find this using tan to the minus 1 of this length divided by this length. So it's going to be tan to the minus 1 of 2 divided by 2, which is going to be pi by 4. So z1 is going to be 2 root 2 cos pi by 4 plus I sin pi by 4. Second complex number, z2, is minus root 3 minus I. So that's minus root 3, that's minus I. So it's going to be the number there. Okay, z2 will be minus 3 minus I. We're going to need to find this angle here. Remember, it's going clockwise, so it's going to be negative. And we're going to need to find the length. The length of this is going to be minus root 3 all squared plus minus 1 squared. Minus root 3 squared is 3. And this is 1, so you're going to get the square root of 4, which is 2. And therefore the argument of z will be theta 2. But we really need to find this angle here first. So we'll call that one alpha. Alpha will be tan to the minus 1 of 1 divided by root 3, which is pi by 6. So the theta 2 will be minus pi plus pi by 6, which is going to be minus 5 pi by 6. So that complex number, z2, is going to be 2 cos minus 5 pi over 6 plus I sin minus 5 pi by 6. So we found z1 and z2 in their polar form. Now we're going to go on and find the multiplication of z1 times z2. So just writing down the general form underneath each one. Right, we don't need to do the actual multiplication for z1, z2. Then the modulus of that complex number will be just the z1 times, the modulus of z1 times the modulus of z2. So that's going to be 2 root 2 times 2, which is 4 root 2. And the argument, all you need to do is add together the angles. So we're going to have to add pi by 4 to minus 5 pi by 4. So adding those together. It would be better if we just do it like that. So it's pi by 4 plus minus 5 pi by 4. That gives me minus 7 pi by 12. So z1, z2 will be equal to 4 root 2 cos minus 7 pi over 12 plus I sin minus 7 pi over 12. For the division of z1 divided by z2, r will be the modulus of z1 divided by z2. So it's going to be 2 root 2 divided by 2, so that's going to be root 2. The argument is going to be z1 over z2. The argument is going to be the subtraction of the two angles, so we have to be careful here. We're going to have to do pi by 4 minus 5 pi by 6. Okay, so we're actually adding that together, and we're just going to get 13 pi over 12. Now that's a slight problem. Why? Well, because 13 pi by 12 is here. It's actually in the third quadrant, and the argument is defined from minus pi round to pi. So we need to find this angle here. So the equivalent angle here is minus 11 pi by 12. So the actual angle we need to consider is minus 11 pi by 12. Be careful, because the argument of a complex number must be between minus pi and pi. And 13 pi over 12 is outside of the range for the argument. So therefore we need to take it back into it by considering the negative one. Okay, so z1 divided by z2 is going to be root 2 cos minus 11 pi by 12 plus I sine minus 11 pi by 12. Right, now these are the actual exact values. If you use the applet, and I attach this applet to the notes of the video, here we have the two complex numbers. This is 2 root 2, and this is pi by 4. This is 2, and this is minus 5 pi by 6 in numerical values. Okay, if we click z1, z2, we'll get the numerical values that we worked out before. Remember, we get 4 root 2, which is about 5.65, 5.66 exactly, and the angle was minus 7 pi by 12, so that gives me minus 1.83. That gives me the multiplication. This is the complex number represented by that. Okay, and then if I click this one, I get the division. Okay, and I get root 2. When I divided the two modulus of the original complex number, I get root 2, and this gives me minus 11 pi over 12. Okay, these are the numerical equivalents. I can't give you the exact values. However, you can pause the video, or you can look at the applet for yourself and put these values in. To fine-tune these, you need to use the left and right arrow keys. Okay, I hope you've understood. This has been a video showing you how to convert two complex numbers into modulus argument form, and then use that to very quickly work out what the multiplication is and the division without actually doing the multiplication and the division. I hope you've understood, and I thank you very much for watching, and I remind you the link to the applet used is in the notes of the video.